Hey everyone. Today we're covering probably one of the most difficult and miserable projects that I've ever built, or at least the first part of it. And this is the WhatsApp machine. And what does it do? It converts text, like so, sends it over a redstone signal, and then turns it back into text for you to read at another location, and it can do it back and forth. So the idea sounds simple, and for the most part it is, but only if you put on a blindfold and look down and forget about all the intermediary steps that you had to go through to get there. How do we get there then? Well, let's start where the idea actually came from. So the idea for this project actually came from a machine I designed a while ago that I called the pulse encoder. And what it would do is on a single set of wire, it would allow me to communicate independently from any of these machines to any other machine, simply by selecting a number from 1 to 5 and hitting the button. And the way this worked was it encoded a pulse. It took your number and it simply just transformed it into a very specific length pulse, which only the station corresponding to that number would be tuned to, and thus it would be the only station to pick it up and drag you over there. The machine itself wasn't actually that complicated. It just consisted of a red coder and some scaffolding trickery, but after I built it, it left me wondering if I could scale it up, sending maybe more possible information or even entire messages. So I came up with an idea. So after thinking about the idea a lot, prototyping, fleshing out design concepts, and eventually creating finished designs, I ended up with a machine that could send entire bodies of text in the form of redstone wire over a single tiny instant wire. But how did I actually get there? Well, the machine's composed of many parts, but today we're just going to be covering the thing that actually sends the data, not the thing that translates it back into text. And this is composed of 3 parts in of itself. The item sorter, that takes our text and converts it into data. The ROM, which tells our computer what the letter is and how it works in the machine. And then what I like to call the heart, which converts that information into the redstone pulses that we send to the machine on the other side. So let's start from the beginning. The sorter. What it does is it takes an item from this chest here, dumps it into this water stream, and that runs all the way across all these hoppers until it finds its slice. This one's 9, but we're looking for E. And the thing is, E is actually just going to be at the start here, because the way I organize this sorting system is based on the commonness of every single English letter, because the ones farther down the line take longer to sort, and it's much less likely that I'll end up with a message entirely composed of question marks. How does the sorter work? Well, it just pulls in only the item that it can pick up, and it sends a signal to the next part of the machine, which is the ROM. So next let's talk about the ROM. The ROM stands for read-only memory, and the reason I named it this is because it's just a memory that's assigned to every single letter, and it tells the machine what is associated with that letter. It looks complicated, but that's just because it's 49 different slices of the same, fairly simple slice. This one just receives an input from the sorter, and that will simply just tell this rail line to come on, which will tell this rail line to be powered twice, which corresponds to 2 7s. Whereas for this line, maybe it will correspond to 1 4 and one of another number. But what it does is it takes each possible letter and it converts it into a value or a set of values, which is just 2 numbers from 1 to 7. So we've covered this lower bit, which is the ROM, and for every letter we input, we get 2 numbers, 1 to 7 for each, which are just dictated by these 1, 2, 3, 4, 5, 6, 7 rail lines, and there's just 7 more on the other side because the sorting system is mirrored. So what actually happens to these signals? They get run all the way to the core, which is this massive, jarbled mess of something that just converts each of these numbers into consecutively higher delays. Some of the people who are more familiar with computer science or maybe software engineering might say, hey, Doesn't your machine run on base 7, quite possibly the worst number system, maybe only seconded by base 13? And I'm going to tell you no, yes, it does. It runs on base 7. But here are my reasons for this. Number 1, 7 times 7 is 49, and 49 just happens to be just the right amount of characters, symbols, and numbers that I actually want to be able to send with this machine. Second of all, I'm not actually doing any calculations with this. Like, I'm just converting information into base 7 and then out of it. All the problems with base 7, the inability to do cohesive addition, multiplication, subtraction, and division, all of these I can just ignore because I'm not actually doing any computations. A good way of thinking about this is that if you take a message and translate it from English into another language, you actually don't care about how horrible and miserable it is to work with the second language as long as you can reliably convert it back into English. Nobody needs to mess with this garbage information because all we're doing is translating stuff into it and then back out of it. Lastly, part of this machine uses scaffolding, which reaches out 1, 2, 3, 4, 5, 6, and then I'd accommodate for the missing value with a note block. And don't ask me why this number matters, but all I'm going to tell you is that 7 just happened to be convenient enough that it would give me all the numbers and letters and symbols I would need without forcing me to step into 8, which would start to make these parts of the machines very, very complicated. Something that you may or may not know about Minecraft is that it runs on a 20-tick clock, meaning something can only happen 20 times per second. But redstone components run on intervals of 2 game ticks, and everybody in the redstone community calls each of these a redstone tick. That includes basically every single machine. And this is 2 game ticks of delay here, being 4, being 6, being 8, but people just say 1, 2, 3, 4 redstone ticks. And the thing is that this machine actually runs at a game tick resolution of 1, meaning that everything runs on 1 game tick intervals. That dictates how precise this machine is at decoding all of the letters I send into it. And the way I pull that off is through scaffolding. You see, it updates how close its support is every game tick, which is why this seems so fast compared to the fastest way to do this with redstone, which would be like this. As you can see, it's much slower, and that's because it's only happening 10 times a second instead of 20. Okay, so why do I actually care about the scaffolding setup I mentioned down there? Well, I can actually use it to make this super simple setup involving a 1.5 redstone tick repeater, trapdoor, scaffolding, and an observer. And as you can see, right between this 1 tick repeater and these 2 1 tick repeaters, 2 ticks, we can make a pulse that happens between the 2. And this gives us an extra level of precision, allowing us for shorter pulses that we can still decode into usable information, as well as encoding it on this side. So we can just generally have faster message send rates, and we can reduce the amount of time it takes to encode each message. Lastly, we have this little circuit here because unfortunately our core only outputs delays, the amount of time it takes for an event to happen. And we want pulse lengths to send to our decoder over there. So what this does is it simply powers on this little repeater loop, which just keeps itself on, and after the delay, we push up this glass block, cutting off the circuit. And however long this redstone output was on for is our pulse length and therefore the letter that we're sending to the machine. Okay, so at the end of it all, what do we have? I mean, I've always had the chat message bar, which allows me to send virtually any kind of message over any distance from anywhere to anywhere. Locations don't matter. So I guess it's probably a little bit more convenient than this little machine over here. But I think it's nice to know that I can send hello world over redstone wire this tiny distance over the course of about 5 minutes, even if I could have ran that information over in 10 seconds by hand. I guess it was still kind of a waste of time, but it's fun, it's gimmicky, and I enjoyed designing it, even if it was kind of a bit of a nightmare to get all these components to work with each other. Hey, welcome to the end. Next video, we're going to be covering this part of the machine, which is actually the decoder. It takes the time to turn all that information we spent so long encoding into redstone wire back into actually readable information in the form of letters, numbers, and in the form of named minecarts. There also might be a third addition to the series that I might be planning at some point, where we try to run this wire through the nether and then back through the overworld. But that's just sort of distant to the future. Anyways, thanks for watching. If you want to see more of this content, remember to like and subscribe, and I'll see you next time.